Hello guys, so I am Kaung Myat Sanda and I will be teaching you about the maximum and minimum on an interval for this calculus lesson. So let's begin. So what will we do? What is maximum and minimum on an interval? So maximum and minimum on an interval, it refers to highest or lowest values of function which is within a specific portion of its domain. So like simply saying, if you look at a graph of a function over a certain interval, let's say from x equal to a to x equal to b, then the maximum is like the highest point, the largest point value of the function which is in that interval, and the minimum is the lowest point, the smallest y value in that interval. So these values can occur at endpoints like x equal to a or x equal to b, or at critical points like inside the interval where the derivative is 0 or undefined. So this is called finding the maximum or minimum on an interval. So in this slide, you can see that there are 4 points: local maximum, local minimum, global maximum, and global minimum. So like for example, function f of x that in order to find that, we first need to find where the first derivative of f of x equal to 0, the critical point, and then we should plug in those x values and the endpoints into f of x, and then we compare the y values, like where the largest is the max and the smallest is the minimum. So where do we use maximum and minimum on interval? Normally we use in optimization, like maximizing profit or minimizing cost in business, or maximizing area or volume in geometry problems, and secondly in physics and engineering problems, like finding the highest point a ball can reach, like maximum height with that, and designing structures with maximum strength or minimum material use, something like that. So thirdly, economics. So in economics, we can determine the optical pricing for maximum revenue, or we can analyze the cost for efficiency. The first example problem is determining the second derivative of each of the following functions. In this video, I will only explain the first problem, the a, h of x equal to 3x power 4 minus 4x power 3 minus 3x squared minus 5. So in order to find the second derivative, we should find the first derivative first. So it is like h prime of x, and then we get 12x cubed minus 12x squared minus 6x, and then we find the second derivative of h of x, which is 36x squared minus 24x minus 6. Problem 2 is like finding the displacement of an object in motion by they already give a fashion, to be honest. So we just need to calculate the displacement at t equal to 3, and then we calculate the v of t at by t equal to 5, and then lastly we calculate the acceleration, which is like the second derivative of s equal to s of t by plugging in t equal to 4. So then we get the answer. The part A, we can see that by substituting the 3 in s of t, and then we get 108 meter. And for part B, we substitute t equal to 5 into first derivative of s of t, which is also the velocity. So we get negative 45 meter per second. And then thirdly, we plug in t equal to 4 in second derivative of s of t, which is also the acceleration, so that we get negative 18 meter per second square. Example problem 3 is when a ball is thrown upward, the motion can be described by the h of t function. For the part A, we just find the first derivative of h of t, and then we substitute with t equal to 0, and then we get the initial velocity, which is 6 meter per second. And then for part B, we consider that velocity is 0 because it is already in the maximum height, so that we get t equal to 0.61 second. For part C, we substitute the h of t with 0, and then we use the formula t equal to b squared minus 4ac over 2a, and then we get t equal to 1.5 or t equal to negative 0.27. T equal to negative 0.7 is impossible because we are considering time, so negative is impossible, so we reject that answer and we only take the t equal to 1.5 second answer. For t, we just substitute the 1.5 in the first derivative of h of t, and we get negative 8.7 meter per second. For part E, we find the second derivative of h of t, and then we get negative 9.8 for meter per second square for acceleration. Thank you very much. I hope you all enjoyed my lesson.
Hello everyone, welcome to this lesson. Today I'm going to be explaining what rates of change is, first principles, how to find tangent equations and normal equations. So let's get started. What is rate of change? Basically, this measures how fast one quantity changes compared to another. And a good example of this is speed, because it measures the change in distance over time. In mathematics, it shows how y, the variable y, changes with respect to x. And on the graph, it will look like the slope. So the steeper the slope, the faster the rate of change. So let's look at two types of rate of change. The first one is average rate of change, and the second one, the instantaneous rate of change, IROC. I already have it written here. So the formula for average rate of change is given here, f of b minus f of a divided by b minus a. Instantaneous rate of change is the slope at one point on the curve. Basically, it's the tangent line, and it's found using the derivative or first principles. So this diagram shows a quick little example of what instantaneous rate of change looks like. So what is first principles? First principles is basically another formula used to find the derivative. So how do we use this formula in a question to find the derivative of a function? Let's find out. So it says find the derivative of f of x equals x squared using first principles. So we use this formula again, and limit h tends to 0. We plug in x plus h into x squared, so x plus h the whole square, we get x squared plus 2xh plus h squared, minus f of x, we plug x into the function, we get x squared, and finally we divide everything by h. So after that we get x squared plus 2xh plus h squared minus x squared divided by h. And after a whole lot of simplification, we get the final simplified expression, 2x plus h, and when we plug 0 into h, we get 2x. So the final answer is 2x. So how do you find the tangent line? Firstly, we can use first principles to find the derivative, and then we plug a certain point or value into the derivative to find the slope. And secondly, what you have to do is plug in the point into the function. You no longer need the derivative, so just plug the point into the function to get the y value, and then you use point slope form here to find the equation of the tangent line. So how do you find the normal line? Basically, you just do what you did for the tangent line, but instead of using the gradient for instead of using the slope, you find the gradient of the normal line by doing the negative reciprocal of the slope of the tangent. So minus 1 over gradient of the tangent is how you find the gradient of the normal. Let's look at some example questions. Alright, this question says to find the tangent and normal equation at the point x equals 2 for this function. So how do we do that? So we use first principles, plus h minus f of x divided by h. So we get x squared plus 2xh plus h squared plus 1 minus x squared plus 1 divided by h, and we've got the limit of h tends to 0. We get we cancel out the terms x squared 1 and 1, so we get limit h tends to 0, 2xh plus h squared over h. After some simplification and factoring, we get the final answer, 2x plus h, limit x tends to 0. So when we replace 0 with h, we get the final answer, 2x. This is basically the derivative. But we want to find the tangent and normal equation, so we need to find the gradients at x equals 2. So the tangent slope is 2 times 2 is 4. The normal slope is the negative reciprocal of 4, so it's my negative 1 over 4. And at point x equals 2, f of 2 is x, so 2 squared plus 1 is 5. So 2 comma 5, we use the slope equation, y minus 5 equals 4x minus 2. We get the final answer, 4x minus 8 plus 5 is minus 3. This is the tangent equation. And to find the normal equation, we just do the same thing again, y minus 5 equals, but we use this gradient, my negative 1 over 4, x minus 2. So the final answer, y equals negative 1 over 4 x plus 1 over 2 plus 5. So final answer, y equals negative 4x plus 11 over 2. This is the normal equation, and this is the tangent equation. So in summary, average rate of change is basically the slope between the 2 points. Instantaneous is the slope at one point, and we can use first principles to find the instantaneous rate of change. The tangent touches the curve, and the normal is perpendicular to the tangent. Thank you guys. Thank you for watching the video.
So today we're going to talk about vector word problems. Let's get right into it. So imagine you're a pilot flying a plane at 200 kilometers per hour towards the north, but there's a wind blowing towards the east at 50 kilometers per hour. Now, what is your direction, and with how much speed are you going? These are important things to keep in mind in the real world when you're flying an actual plane. There are a lot of factors that can affect your speed and direction, and to do these questions, you need to have vector knowledge. So let's get into the basics. So vector is going to have two parts, the head and the tail, and you always align them head to tail, not head to head or tail to tail. It's always going to be head to tail. Now the second is resultant vectors. After you have aligned them head to tail, you can connect the first tail of the vector to the head of the second vector, and you get the resultant vector. Now the important thing here also is going to be that vector addition can be interchangeable. So a plus b is going to be b plus a, so on and so forth. Now imagine you have a parallelogram with vector a and b and c and d. Now, in this case, vector A is going to be the exact same as vector C, and vector B is going to be the exact same as vector D. They have the same magnitude and the same components. So these are very, very convenient things that we can use to find the resultant vectors to align them head to tail, and these are going to be convenient later on. Now bearings are very easy. You should have covered this in your 10th grade or 11th grade as the most, and bearings always start from the north and they go clockwise. They don't go counterclockwise. They don't start from south or east or west. They start from north and go clockwise. Splitting vectors. Now that you have a vector or a resultant vector, perhaps you can split them into two vectors, which is a very important thing to do. Now here you're going to have vector v but the x component, and vector v but the y component. Now again, these are going to be interchangeable, so like a plus b is equal to b plus a, and also you can use trigonometry to manipulate and use these things, like vector v, the y component of vector v is going to be vector v multiplied sine theta, and x component of vector v is going to be vector v multiplied cos theta. And vector magnitudes is the last part. This is also very easy. You just use the Pythagoras theorem, and yeah, it's very convenient to find the magnitude of the vectors. Let's get into the questions. So if a boat is attempting to cross a river that is 200 meters wide, the boat speed in still water is 5 meters per second, and the river has a current flowing downstream of 3 meters per second. Question: at what angle upstream should the boat head to reach directly across the river? So now, the important thing to keep in mind here is this 5 vector is going to be the boat. So what angle is this 5 vector going to have to be for this vector to reach directly across? So to clear up, this 3 is going to be the downstream effect of the river. The 5 is going to be the ship, and the 5 is going to be where it's headed, but this arrow is going to be where it's going to be landing. So to use this, now that you have set up a right angle triangle, it's very easy. You just use sine inverse and you find the angle. In this case, it's 36.9 degrees. And number B, how long will it take for the boat to cross the river? Now you find the magnitude of the resultant vector, and then you use V is equal to S over T. So you just do that. You get 4 meters per second, and you use V is equal to S over T. You get T is equal to 50 meters per second. That's enough for me. Good luck on your vector quiz and exams.